Yeah, it was
like in the past 4 years.
That's great though. Interesting.
Yeah, I wanted to
something new.
I used to, but I don't think I can. So
This is my outlet.
All right, good evening, everyone, and welcome to yet another edition of DCiOS. Hope everyone's had a good time. I know it's been a little while. I know we've been hoping to be back at the Washington Post for a while, but it will unfortunately be a little while before we can be there. But luckily, we can still come here at Capital One. So I'm going to kick us off. Welcome, and hope everyone's having a good day. I think we all know there's an Apple event today, so we can talk about that for a very quick second. But just in general, for people joining over Zoom, you're muted. If as you have questions during the presentation, please feel free to ask them in the Zoom chat. I will probably allow for general unmuting at the end of the presentation, but just during the presentation, since I think we're expecting a bigger group today, I'm going to keep the lines muted until then. So we had an Apple event today. Nothing new was announced, right? Right? Nothing new was announced. I mean, just some iPhones, maybe a few watches. Oh, I guess that thing we call a lightning cable's finally going away after 10 years or something. Well, maybe unless if you use a keyboard or a phone or an AirPods Max. But for most of us, maybe we will finally not see lightning cables anymore. But we can talk about that a little bit more at the end. Obviously, we're not here to talk about phones or watches or the lack of lightning cables. We are here to talk about SwiftUI architecture and best practices. So with that, I will let us jump straight to the talk, and I will hand it over to our speaker.
Hey everyone, how's everyone doing? Let me see here. Can you see my slides? Well, I guess I have to run it, but let's go ahead and. All right, everyone can see the slides? Okay, all right. All right, thanks everyone for coming and thanks for the opportunity, Scott. Thanks a lot. So I'll be talking about SwiftUI architecture and best practices. Here's a little bit about myself. My name is Mohammad Azam. I go by my last name, which is Azam. I'm an iOS developer, developing since 2010. Right now, these days, I'm doing a coding bootcamp instructor, so I teach for a coding bootcamp. I'm also an instructor on Udemy, so I do a lot of different courses on Udemy, and also I license some courses to LinkedIn. I'm an author and a speaker. I actually just came back, I think 3 days ago or something, a couple of days ago to try Swift conference. And before that, I was in New York for NY50. So it's always fun to meet new people, share ideas. And a couple of years ago, I was actually presenting for the DCiOS group. And this is the title of the talk, which was architecturing the SwiftUI applications using the MVVM design pattern. So 2 years ago, a little bit maybe over 2 years ago, I did this talk in which I said that, well, if you're developing SwiftUI application, you should use the MVVM design pattern to do that because that just flows in nicely. And today I'm here to tell you that I was actually wrong. All right. And this talk is going to be my experience with SwiftUI when I started with 2019. Now, the reason that I was wrong, we have to go back and see that what went on, why was my thoughts change about a certain architecture when you're using SwiftUI, and what problems did I face and what did I discover over creating probably around 150 to 200 prototypes since 2019. So in order to understand this, we have to a little bit go back to 2019 when Apple announced SwiftUI. I was really happy because I was already working with React and Flutter, and I'm like, well, this looks pretty similar. I mean, we're using Swift as a language, but it's pretty similar. I mean, if I know React, I've been teaching React, I know Flutter, I've developed some apps in Flutter, so this is very similar. But then the question become, okay, when I was using UIKit, by default, everything was in MVC, Model View Controller. But when I'm creating SwiftUI application, what should I do? So I didn't really pay that much attention at that point. I'm like, okay, I'm just going to do what everyone else is doing. So I'm just going to use MVVM. And that kind of started on my journey with MVVM, keeping in mind that I have worked a lot with MVVM in terms of WPF applications for very large, extremely large Fortune 500, Fortune 100 oil gas companies. So it's not, MVVM is something new to me. I have worked with a lot of MVVM really big apps before. So I'm like, okay, yeah, everybody's using MVVM, so I guess I should also be using MVVM. Okay. And I went, as I usually do, a little bit crazy. I started writing books on it. I start speaking engagements on like how MVVM is like the most awesome design pattern to use. Once again, there's nothing really wrong with any design pattern. It's just the way that you use it, or if you're using a particular design pattern for doing the, wrong design pattern to do the different kind of work. So design patterns are just patterns. So it is not like good or bad. It really depends on how you're using it. So I started creating these different videos and courses and writing articles about it, and more courses and more articles. Actually, if you go on Medium and search for MVVM and SwiftUI, my article kind of like comes on the top. And also speaking engagement. So I did all of that stuff. I invested heavily in MVVM with SwiftUI. Every application I created with SwiftUI in 2019 and 20 and even 21, I guess, it was MVVM. But I was always like, you know what, I'm writing a lot of code and I know Flutter, I know React, and we don't really use MVVM over there. So already 3 years, pretty much 3 years passed by, and I'm still confused. Most of my applications were clients and server, as I think most of your application would also be if you're working for enterprise companies or, developing anything. These days, server is very important. Or core data applications. So you can substitute core data with Swift data, kind of like the same thing. So either they were client server or they were core data applications. Some of my application, or this is a very small part of it, like taking an example of some of the applications that I wrote, they were consisting of only 5 or 6 different screens. Like you can see over here, like add movie, add review, movie list, movie detail, review list screen. So these are screens. Screens simply mean views, like views in SwiftUI. And every single, if you go with the MVVM, kind of like a classic model, how to implement MVVM, every single screen was controlled by a view model. So for a movie list screen, we have a movie list view model. For add movie screen, we have add movie view model, and so on. And obviously, there are multiple ways to implement MVVM also. I have seen like hundreds of different ways people write MVVM, but I think this is the most common one. I mean, maybe you're looking at this, you're saying, oh, I don't really use it like this. Okay, that's fine. But I think this is the most common one, right? You create a screen, you create a view model for it. You create a screen, you create a view model for it. I'm saying screen, I'm not saying view. So I'm very careful with my words over here, because a view can be something reusable, and maybe you don't really need a view model for that, all right? So what we do over here is that you can see that you have movie list screen talking to the movie list view model that is talking to the HTTP client, because it's a client-server app, and then that talks to the server. The same thing goes for add movie screen, add movie view model, going to HTTP client, and so on. And most of the time, I will end up with code kind of like this. You have a movie list view model, observable object. You have add movie view model, which is observable object. You have movie detail view model, which is observable object. Observable object is actually the source of truth. Each of these view models that you're creating based on the new screen that you're adding will also need access to the HTTP client, because they need to communicate with the server. Now, you can create HTTP client protocol and factories and all that stuff, but eventually you do need to inject it to your view model so that you can do something. So over here, you can use a factory. I'm just obviously injecting concrete implementation just for the sake of simplicity, but you can create a factory, you can create whatever. And this is going on for all of my screens in my application. And this was kind of like annoying to me that, oh, I have to do all of this stuff to get this thing working, all right? But looking at this diagram, and we created 3 different sources of truth because we have 3 screens. We actually have like 5 or 8. So every screen creating different brand new observable object, which is basically a view model. But what is the source of truth in a client-server app? It's the server. The server is the source of truth in a client-server app. That does not mean that the server is the only source of truth. You can have more sources of truth. Maybe you are working with a location manager. Maybe in a server client app, you have a core data or Swift data. We're not talking about that right now. We're just talking about a client server app, a simple app, all right? So if the source of truth is the server, why did I end up creating movie list view model, add movie view model, movie detail view model, review list view model, add review, 4, 5 different sources of truth? Why? Why did I do that? It just adds more code and more code and more code. Also, the other problem was that sometimes you will have a view hierarchy where you have a deeper view, a very nested view, which is saying that, hey, I need some data too. Can you give me some data? And usually when you're working with SwiftUI, you use environment object. But the environment object is only available inside the view, just like the fetch request, section fetch request, query from Swift data. All of those things are only available inside the view. So you get to questions like this. Well, how do I pass environment object into view model? And this is obviously on Stack Overflow, and you can look at the answers where you will have to kind of like inject the environment object to your view model. And then you have to inject the environment object to another view model and another view model, and it just becomes a pile of garbage in the end. All right. So I'm like, okay, I'm working on these apps. This is getting me nowhere. I'm writing a lot of code, and it's not like the apps are not working. They're working, but I'm creating a lot of code to do some really basic things. So I put on my geeky glasses and I went back to, well, where do we even begin learning about MVVM, even though I have worked with larger companies using MVVM? So MVVM is just a fancy name that Microsoft gave. It's actually called the presentation model. And you can see the date over there is 2004. I think it was even released, or it was talked about a little bit even before that. So presentation model is actually MVVM with just a fancier name. And one of the things that Martin Fowler talks about in his presentation model article is thinking between the presentation model, which is your view model, and the view. And the last part is kind of really interesting. He says that ideally some kind of framework could handle this, which I'm hoping will happen one day with technologies like .NET data binding. And he was right, because .NET data binding was actually released in the form of WPF, Windows Presentation Foundation. So Windows Presentation Foundation contains the binding. Binding simply means that whatever you type in the view, that will be automatically synced to the view model. Whatever you have in the view model will be synced to the view. And this is a very basic code for WPF. On the left-hand side, you can see a XAML file, which is just a display, meaning just XML, XAML or XML. And on the right side, you have a C# file. So you have the left side, which is the view, and the right side, which is the view model, which is a C# file, like a Swift file. And whatever you type in your text box on the left, it automatically goes to the title field and on the year field, which is defined by the view model on the right, which is add movie view model. So this is the binding that Martin Fowler was talking about, that he doesn't really want to, or he doesn't like to do manually binding those things. But now with WPF, you can do it in a nicer fashion. If I had to create the same screen, a very simple screen with add movie view model in SwiftUI, how would it look like? That's what I'm going to do. I mean, that's literally what it will look like. I would have an add movie view. I will have a couple of state properties, and I would simply say text field binding to the title, text field binding to the year, and a save button to save movie. All right. Well, what about validating? But I mean, you do have to validate, right? Because people can just press a save button and it's not going to work. Well, yeah, validation, you can do that. Just write the validation inside the view. Okay, so now it was making more sense to me that, hold on, I didn't really have to create an add movie view model. I can just write this validation right inside my view. And I can just check on line number 31. If the validation is failing, then I will simply disable the save button. Now, when people look at this code, they're like, oh, wait, you're putting business logic inside your view. That is bad, bad, bad. No, because you're wrong. Look at this HTML code. And I'm glad that I'm a web instructor, because in HTML, you write this code most of the time. I mean, if you have done any HTML, you can see that there's a required tag on the input, and there's a pattern attribute, and there's another pattern attribute, and the required. These are all simple presentation logic. All right, these are just attributes. You can put it on your HTML. This is not the business logic. It's not. The business logic is directed to the domain. We haven't even got to that point. And in a client-server app, the domain mostly resides on the server, not on the client. Yes, there will be some instances where there will be some, domain on the client. Maybe you are just caching the data in your Swift data or core data, and then you're putting all the rules. But we'll talk about that a little bit later, how you can achieve that. But this is not a business logic. This is just sanitizing the data, just validating user input. If you want to test this out, I think the other part when people talk about this is, well, how do I test this out? How do I test this form valid? You have logic inside the view. What do I do to test this out? Well, if you want to test it out, you can actually move it into a struct and then test out the struct. But I'll talk about testing a little bit later as a screen with just title and year, and I just want to check if you're adding something to it or not. I would not even bother creating an add movie edit config struct. I would just do it in Xcode previews, which is much better. So after creating and recreating the apps using this particular pattern that Apple is pushing out in its source code, I came to realize that the view itself is the view model. We don't really have to create view model for every single screen. There's no point of doing that. The view in SwiftUI is completely capable of binding using add state, add binding, add state object, add environment object. Everything is inside the view. So you can use it. Now, I know that everybody's thinking right now, okay, so you're going to shove all the stuff in the view. No, we're not going to do that. Just keep watching. So this means that all of these view models that I have created, all of these sources of truth, which is using HTTP client to get the data, to add the data, to show the details of the data, I can remove that. I don't need that. And in some instances, use case number one, my view can directly talk to the HTTP client. And whatever the HTTP client is returning you, we can just display it on the view. Let's take a look at a very simple example. This is use case one, by the way. This is sometimes I do that, sometimes I don't. This is a use case. The news list screen, which is supposed to display a news item, you can see on line number one. I don't know if I can actually, let me see. There we go. Right over here, you can see that I'm using HTTP client. I'm getting it from the environment value. I get that stuff. And somewhere over here, I just created this helper function like load articles, which is going to load some news articles. It's going to load it and assign it to the article state object, which is a local state. And that's literally it. I mean, I didn't really have to do anything. I didn't have to create any view model for that. This articles that I'm trying to display is the news list screen is the only one interested in those articles. So we just fetch the articles and we just give it to the local state and we're done. Nice and simple. If you want to sort your articles and all that stuff, well, we don't have to create a view model for that. You can just write your properties and then sort it right there. Now, I know everybody's thinking, well, how do I test it? How do I test it? How do I test? We'll get to that. We'll get to that. Nice and simple. All right. Now, if your view news list screen is getting bigger and bigger, and you're like, oh my God, that's like a lot of stuff, then you have to come down over here and decompose it correctly. Right now, we can decompose the list also, but I'm just going to leave it like that. It's not big. It's perfectly fine. But if I'm getting like a lot of crazy stuff over here, then I would have to talk about composing my view into multiple views, like article view. Article view is a nice small view which shows the article. Nice and simple. All right, so this is use case number one. When do I use this use case number one? Well, when the news list screen is just getting the data from the server, and the news list screen is not really modifying the data, it's just displaying the data. Nobody cares about the data except the news list screen. But that's not always the case. Sometimes you get the movies or news and you want to add a news item. Well, in those cases, I can just put an aggregate model layer. Now, aggregate model is just something that I'm giving it a name. You can call it like a global view model, or you can call it a data store. You can call it whatever you want. That's perfectly fine. The reason, and the main reason that I'm going to explain later, is we didn't really added this. And by the way, this aggregate model is actually an observable object. But the main reason is that we didn't add this model because we added a screen, because we added a view. We added this because we actually wanted the observable object a source of truth. So let's go ahead and take a look at, and this is most commonly what I use in my applications, because in my applications, I am actually adding and removing and filtering and maybe all of those different things I'm doing. So this is what it will look like eventually. So this is a pattern that I just showed you. It's shown in WWDC Data Essentials. This is the actual diagram from Apple. Obviously, I've recreated the diagram, but it looks exactly like that. And Apple has shown this in their sample application, Fruta and Food Truck apps. Now, at this point, most people will be like, well, are we taking architectural advice from Apple? Are you completely gone crazy, Azam? No, I'm not actually taking any advice from anyone. This advice is based on 3 years of research, creating more than 200 different prototypes, trying out MVVM, container pattern, MVC, Redux, Viper, everything, and then going back to the Apple documentation and figuring out how did they do it, and that made much better sense than anything that I came up with. All right. So check out the Apple documentation or Apple sample code for Fruit and Food Truck. This, if you look at the Food Truck application, if you go and download the code, Apple is not really performing any HTTP request. It's actually getting the data from JSON file, or it's like a hard-coded data. So you might say, okay, hold on, how do I do it? I mean, if I'm building a client-server application, how can I go and, get the data? Because Apple is not showing us. Well, Apple is showing you a hint in the use Xcode for server-side development. That's the name of the talk. And at 14 minutes, 6 seconds, Apple does show you the screenshot for a split second before it goes away, where Apple actually converts a food truck application into a server side. So you can see over here, now I will write it a little bit differently, obviously, but you can see right there, we have the food truck model. The food truck model is kind of like a data store or the aggregate model. And in a small to medium size app, you only might have just one observable object, which will get the data from the server. Now, food truck model is not only maintaining the state for the food, but it's maintaining the state for everything for in your application, the truck, the orders, the server donuts. So instead of creating a food truck or whatever, the food list view model, add food view model, food detail view model, food whatever, donuts view model, we just create one particular view model because our app is small or medium size. And that particular observable object in a client-server application kind of maintains the entire state of your application. And over here, you can see they are creating the client, which is the HTTP client, and they just, get the data. The client itself is, or the HTTP client is itself is stateless, so it just returns you the stuff and then assigns it. Nice and simple, easy to use, super awesome. So looking at that, I came up with, well, not I came up with, I just designed my own thing, kind of like this. And you can use Actor as the model, that's fine. You can see that I'm passing movies HTTP client over here. That can be a protocol. If you want to mock it, unmanaged dependencies, that's fine. But that's the only observable object I have in my small to medium size application. And that controls the entire state of the app. All right. So this model, and you can call it anything. I'm calling it model, but I couldn't come up with a better name. You can call it data store. You can call it whatever you want. I have seen people using this particular pattern, but they call it view model, like a global view model. All right. And then you can inject it into the environment, and inside the view, you access it using environment object. So over here, you can see on line number 60, once the model, which is a movie model, or injected into the environment object, I can simply access it inside my view, and then I can use the save function or add movie function, and then it's just gonna work them all, right? Now I know that Ed is commenting over there, one view model to all rule them all. That is actually not true at all, and I'm just gonna answer that right now as we move forward. So what we look at it over here is that the screen, when I started using the view model, so when I started using the MVVM pattern, I was creating view model per different screen. I mean, every screen I'm adding, every view model I'm adding, every view model I'm adding, a new source of truth I'm adding. Why? The source of truth in a client server app is a server. So why do we have like 30 different sources of truth? When we start moving into a different kind of like what Apple suggests, and Apple doesn't really call it MV, I mean, it's just a random name that people are calling it. Then we create observable object. We do create view model-like things, but we don't add these things on the basis of the screen. All right, we add them on the basis of the context that you're working in. So we'll see in a little bit later when I talk about larger apps that it's not one view model to rule them all. Yes, if you're working in a small to medium-sized app, you can use one view model and that's all you need. But in a larger apps, that's not going to work out. So don't jump to the conclusion, Ed. I'll answer you in 2 seconds. Code is not an asset, it's a liability. So the more code you write, the more stuff you have, the more testing you do, the more maintenance you have to do. So just because you created 30 different view models, now you have to freaking maintain that. All right. What about bigger apps? And that's where my answer comes. Nobody's limiting you to adding more observable objects. Just don't add observable objects or view model, if you want to call them that, based on the number of screens you're adding. Because you can have an app, a larger size app, 100 screens, 200 screens. Do you really think you will have 200 different sources of truth? I mean, really, come on. Come on, Ed. You really think you'll have 200 sources of truth? Nobody can answer that question, but I'll continue. Multiple aggregate model, there you go. So don't add view model per screen. That multiple aggregate root models based on the bounded context of the application. Bounded context, what the hell does that mean? Bounded context means the context in which you're working on. Taking a look at this example, and this is again the screenshot from Apple, I've a little bit modified it. If you're working in an e-commerce application, you have catalog. Everything deals with a catalog, right? Adding a new item, removing item, adding inventory, blah, 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 and then fulfillment, adding, order, and then fulfilling order. What will be the time for this fulfillment? Based on the bounded context, based on that stuff, then you should add a new observable object, not because you added a screen, but because you're working in a different thing, different bounded context. Here's a much bigger view of that. All right, so if you're working in a much larger application, you can have onboarding, which is like which has an onboarding UI. And UI over here, these are just folders or packages depending on your application. So catalog UI, catalog, inventory UI, inventory, ordering UI, and ordering. All of these can be folders, but all of these can also be, if you want to reuse it in some other application, they can also be packages. So catalog, inventory, ordering, and shipping, all of these are different observable objects that you're adding. All right. Now, if you were creating this using the classic MVVM approach, how many screens for the catalog UI you will have? Let's say 10. 10 for each. So 10, 10, 10, 10, 40. 40 screens, 40 view models. Wouldn't it be much easier if you have like freaking 4 instead of 40, right? Now, these might be a little bit deeper observable objects, all right? That's fine, all right? And whenever you're creating these observable objects, sources of truth, based on the bounded context, you have to consult with the domain expert. So if you're working on a very large project, there will be a product manager or someone, the domain expert, that can tell you that, oh yeah, a catalog, we can divide it into 2 more or something like that. All of these things, they kind of talk about they interact with the same exact service, all right? Like a HTTP client, MyStoreKit, whatever you want to call it. So this is a much nicer approach, I see, because you're not introducing view models per view model after view model based on the screen. You're adding view models based on the bounded context, or you're adding view models, one view model for small or medium-sized app. Even for a medium-sized app, which obviously this one is not, but even for a medium-sized app, one observable object, if you're building a client server, will be more than enough, all right? I mean, if you look at the Fruta app or Food Truck is actually a pretty decent sized app. They just use one particular, observable object. Now, you can call it view model, you can call it data store, whatever, but they just use one of them, and that's perfectly fine. I actually wrote a very, very big article, very long article. So it might take you like 45 minutes just to read that, in which I talk about this whole thing, that my experience with working and the problem with MVVM, with SwiftUI, and then trying to like make it much simpler. If you try to use the classic MVVM or for your SwiftUI apps, it's basically kind of like you're wrapping MVVM with MVVM, because SwiftUI is already MVVM. So you're going to wrap it up with another layer of MVVM on top of MVVM. So don't wrap it too many times, all right? And one of the things I talk about the article is the same thing that I've been saying again and again, is that the primary motivation to introduce a new observable object should stem from the integration of a new source of truth, not because you added a new screen, all right? So this was client and server apps. What about core data? Can this work with core data? Well, let's go back and see what I did 3 years ago, or in 2019 and 20 and 21. So when I was working with core data, I would have a movie list view and add movie view, or movie list screen, I should probably call it. And the add movie screen should be in a sheet, like a modal. And what will happen is that the movie list view needs to refresh, because now you added a movie. So the refreshing part, there's many different ways of doing that. You can refresh it, or I was refreshing it because I was like, no, I'm just going to use MVVM. I'm not going to do this. I'm not going to use environment object. I'm not going to use fetch request. I was completely against fetch request property wrappers. So if I want to refresh my parent because, the movie has been added from a modal, I can use combine. I can call populate movies on the dismiss of the modal. I can, if I'm completely out of my mind, I can implement NSFetch results controller, which is like the old school way of doing things. And my every view model will conform to, this NSFetch results controller delegate, and that will cause it automatically to refresh. I've even seen some people passing in an actual flag. Like if they want to refresh the parent because somebody has added a new item, they would pass a flag refresh to the child view or the modal, so that they can change the modal, so that they can trigger an update of the view. I mean, this is just insane. What is going on over here? I mean, this is like we're fighting the framework, all right? Just go and use the fetch request or section fetch request and get these things over with. Why are you implementing all of the fetch requests? It's doing all of this. I mean, this is just for one view model. You can do the same thing with just one line of code, which is simply using the fetch request itself. So fetch request will kind of look like this, which means that just give me all the list or all the movies or whatever. And if you do want to put your fetch request into somewhere else, like the actual request, yeah, you can do that. So you can see over here, you can create a movie list, which is your manage, that mapping object that you have. What is it called? An manage object or something like the model object. And you can just create an all function on there, and that will return you the fetch request. That's perfectly fine. I mean, that's much better than writing an fetch results controller or passing in the refresh tag or using anything else. All of these things that Apple has given to you, fetch request, they are highly optimized for SwiftUI. So when you're using fetch requests or section fetch requests or add query in Swift data, they're very optimized for working with SwiftUI. All right. So don't try to reinvent the wheel. People will go, crazy lengths that, oh, I'm not going to use fetch requests because I don't really want to put my, data access thing in my view and all that stuff. What if I change my stuff and I'm not using core data anymore? Well, I've been working for like 20 years, and I don't recall any moment where 3 months down the road, we're like, okay, we're just going to switch Postgres with MongoDB. All right. Maybe it does happen, but I can tell you from experience, it doesn't happen a lot. And I've worked with a lot of different ORMs and Hibernate, Lightspeed, Link to SQL Entity Framework, and SQLite. So with all of this understanding and with all of this stuff that I worked on already with .NET Framework and JavaScript, I started to see that, okay, this kind of a pattern that Apple is using or advocating, it kind of looks like an active record pattern. So for creating or for using SwiftUI with core data, I ended up using similar things. So instead of using like, okay, I'm just going to create one observable object or things like that, it wasn't really making sense. So I started using kind of like this pattern, which is all the logic, the business logic that you will have will go inside your model object or manage object, the class, all right? And in Swift data, it becomes much more nicer because, you don't really have those mapping files and all that stuff. Now, one of the problems that comes is when you're using the fetch results, how do you work with the previews? Because you can't just create an instance of fetch results. So if you want to display all the reminders, you can't just create, an instance on an array of reminders or fetch results and pass it. Well, one of the ways that you can do that is by adding a container view. So over here, you can see that I added a container view, which is just for the sake of the previews. And the container view itself is actually making the fetch request. It gets the stuff, and then it passes it down to our actual view, which is reminder list view. And that's how it will work. All right. So yes, it does have that. You have to add some lines to create container views, but you can make it work if you want to. I wrote a very detailed article of Swift data, which I think some of the actual code might be a little bit obsolete because Apple keep on changing stuff for Swift data, which is fine. I have to update that. But in this article, I talk more about how you can, how you can structure and architect your Swift data / core data applications. There's also a really good talk, lessons learned rewriting SoundCloud and SwiftUI, and in which they talk about that they use Viper and MVVM, and they created their own data access layer. And when they submitted the app to the App Store, the Apple rejected the app, saying that your app is like 10 times slower than the competition, so fix it. And then they were like, okay, how can we just design the app like if we work for Apple, like using the fetch request, using section fetch request, using all the things that Apple is providing in property wrapper for core data. And then immediately their time was cut off half, and they were able to submit the app and get it approved. All right. So for Swift data and core data, try to look into using a variation of active record pattern. That kind of works. All right, so now let's go ahead and talk about testing, because every time there's people are writing code in their view, which is actually a view model, the first question people ask is, well, how do I test it? How do I test it? For me, the testing is all about confidence, all right? Which means that if I'm confident it's going to work, and if I'm confident that Xcode previews, or if I can run it on a simulator, or if the logic is simple and I'm confident that I don't really have to write a test to make sure that when I initialize the object, all the fields are initialized, these kind of things, then I'm not even going to bother writing test. Let's take a look at the example over here. So we have this login view form validation, which is login view, and this contains the username and the password. It contains also a property called is form valid. And the first thing that people see this is like, well, how do I test this? Because I was using login form view model and I can write a test for it, but how do I test this, right? If you ask me personally, how do I test it? I will just test it manually. I will test it using Xcode previews. Previews are on the side. I can test it. I'm good with that, all right? Apple also came, and the weird thing is that I actually talked about in March 2023, and then Apple came out in June 2023 and posted this slide. This is from Apple. Previews are like tests. Like test, yeah, that's the right wording. They're not really tests. They're kind of like test. So if you have like a logic, like simple logic, and you're confident that's going to work, then use Xcode previews to preview it. Create multiple previews, obviously, if you want to test like a light and dark and all those different cases, like font sizes, dynamic fonts, and all that stuff. You can create multiple previews for those testing out things. But if you're like, no, I really have to please someone and I really have to write the test for it. Well, okay, I guess. I mean, you can go ahead and extract out the actual logic and into a struct, like simply a data struct, meaning just there's some holding data, and you can waste your time writing the test if you want to. I mean, I wouldn't even bother writing a test for this. I mean, I will just use previews, but if you want to, you can go ahead and do that, all right? That's fine. Taking a look at another example, if you have a content view which has these filtered products. Now, filtered products, if that's filtering based on the price, I can quickly test this using Xcode previews, but if you insist and you want to write the test for it, extract out the actual logic into a struct, test out the struct. You're done. All right, so everything is testable. I mean, I usually use Xcode previews unless I'm like testing something that requires a lot more parameters, and I'm like, okay, I don't understand what's going on, then I'll be taking help from testing. Don't write unit test. Don't write unit tests for your view model to verify the user interface. This is kind of like, okay, this is common sense. Why did you even add this slide? I didn't really even wanted to add this slide, but I talked to a lot of people. They're like, yeah, we don't really test our UI, which is fine. We just test our view model, and if the view model test passes, our UI is working. That's not really true at all. I mean, if you're not writing tests for the UI, that's fine. I'm not going to judge you. I mean, I don't really write tests for the UI. I mean, depending on the use cases, I guess. Not for every single thing, but yeah, the testing that you're doing for the view model has nothing to do with the actual UI. That's just testing the view model. Let's take a look at a very simple example. We have a counter view over here, or the counter view model over here, and the content view, and we're testing that the count is incremented. Okay, well, we will write a test over here, and the test will pass. But the test has nothing to do with the UI. The test is only checking that if the count has been incremented in the view model. So basically, you're testing the logic in the view model. Nothing wrong with that. But you can't really say that, okay, the UI is working, because the UI is not working. All right, well, let's take a look at that example. Do you think this test will pass? Yeah, actually, this test will pass. But how is that test passing? We don't even have a button to increment the counter. So that's what I'm saying. I know it's kind of like very common sense, but some people will be like, okay, I'm using my view model test just to make sure that the UI is working. No, you're writing your view model test to make sure that the logic in the view model is working. That has nothing to do with the UI is working or not. And here's a simple proof, because I don't even have the UI. I have deleted the button. There's no button, but the test will pass. Okay? So how do we pass or how do we test the UI? Well, if you actually do want to test the UI, then write, drum roll, a UI test. Now, UI tests are slow. Absolutely, they are slow. So don't write every single UI test for like every single thing that you're doing. Usually, it's a good idea to write the UI test for a couple of UI tests per feature, like 2 UI tests per feature and 1 kind of like an edge case. So if you want to write a UI test, write a UI test that checks the longer path. Like as a user, I should be able to log in and go to my dashboard and add a new project to my profile, something like that. So that will be a good UI test, as it's going to check all of those different things. Make sure that you're testing the behavior and not the implementation details. Whenever you write a test, make sure that your test is not checking the implementation, because the implementation details can change. If your test is failing because you refactored your code, then it's a bad test. It's a brittle test. Refactoring should not change the behavior of your implementation of your whatever you're checking of your feature. Refactoring should still produce the same results. So if you're refactoring code and your test is failing after refactoring, that's a very brittle test, because implementation can change. Don't use mocks for managed dependencies. Managed dependencies simply means dependencies that you control. If I am trying to access a payment gateway, which is hosted by someone else, some other company, that's not a managed dependency. I don't control that. If I'm trying to access core data, which is running on my simulator, yeah, that's a managed dependency. I'm not going to mock it. Maybe I'll use in-memory testing, but I usually just go with the real thing. I will just write to our core data, remove it when the test is done. That's the important part. All right. This is a really good talk, TDD, Where Did It Go Wrong, by Ian Cooper. And he talks about a lot about how you should be testing the behavior and not the implementation details. And one thing to always remember is that the test is the isolation, not the thing under test. A lot of people get this misconception that, oh, I'm testing, so I should completely isolate my test. I shouldn't access the database. I shouldn't write to a file. That's all wrong. If you want to access the database, managed database, meaning you control it, go ahead and do it. That's perfectly fine. Just make sure, and that's the most important part, to remove the thing that you inserted into the database after the test is done, or else it's going to fail or have a weird effect on the future test, because now there's some data in the database, or you may have created a file that you didn't delete it. So make sure that you delete all that stuff. All right. Ken Beck talks about that I get paid for code that works, not for tests. So my philosophy is to test as little as possible to reach a level of confidence. So it's all about the confidence. Obviously, when you read this, I'm not saying that you shouldn't write tests. I'm saying that you should validate that what tests you have to write and what tests you don't have to write. Usually, in most applications, the most important part is the domain of the application, the actual heart of the application. So make sure you test that thoroughly, all right? But you don't really need 100% code coverage. You're not sending a man to the moon, or you're not really performing some sort of a heart surgery with your device. Unless you are making a device and running a software to perform heart surgery, then make sure it's covered 100%. All right, let's talk about some miscellaneous topics, rendering versus evaluation. When I started with SwiftUI, I thought that every single time the body gets executed, the view is rendered again. So over here, we can put print changes, and every single time the print changes is fired, it means that the whole content view is recreated from scratch every single time. But that's actually not true. So I was wrong. The body, this simply means the body is evaluated, all right? if you look at this code, there's only one particular view that is actually using the count property, which is this text view. So as I press the button, which is on the next line, button increment, the count is incremented, but the only view that is using the count is the text. That's the only view that's like, hey, I want the value of the count. So the whole view does not get destroyed. The whole view might get diff, meaning it will be evaluated. So if UI is going to look at it, kind of like this. So if UI is going to look at it, somebody's going to change the counter. Only one view is using the counter. So if UI is going to say, okay, well, the button didn't use the counter, the list didn't use the counter, and the first thing is just displaying a text with a string counter, so that doesn't even make any sense. But you're the only one, red one, you are the only one who's using the count property, and that has changed. So I'm going to go ahead and destroy you, and I'm going to replace it with a fresh view. And that's actually what happens behind the scene. So the content view doesn't get destroyed. It's only the view that is changing gets destroyed. I mean, even you can think about it. If you type in a text box and that value is going into a binding variable, the body is getting reevaluated again and again. That doesn't mean that your content view or whatever view is getting destroyed again and again. Navigation. So navigation got a really good update with, I think, iOS 16, when they introduced the navigation stack. And now you can create programmatic global navigation. This means that kind of like with Flutter and React, you can create globally, you can create those routes, and then you can, ask the user to go to that particular route. So over here on the left side, you can see I'm creating a route, which is home, login, detail, reviews, reviews, detail, and I'm exposing that as a environment value, okay? Originally, when I wrote the article, I exposed it with the environment object, but it wasn't really making any sense because environment object, you usually put the things that you want to, like a data that you want to display it on the screen. I don't really want to display the routes on the screen. I just want to act on the route. So I used the environment values. In my root view or in the app file, I created all these routes. You can move it into a different file if you want to. And now from any single screen, I can only type this small code to go to a particular route. Nice and simple. Kind of like reminds me of React Router that allowed you to navigate to a particular route. They actually use the same exact code. I mean, not code, sorry, same exact function naming like navigate. So that is, I got it from there. All right. So if you do have a new route, you just add it in your right-hand side on the Learn app, and then just go there. There are certain things that I removed from the right-hand side, like unbinding. Like if you are on a route C and you want to jump to route A, you can do that. That's called unbinding. But just to save some space, I've removed that. You can read my article. In that, I do cover unwinding routes. So if you are on certain screen and you want to jump to another screen, you can do that. View events. Sometimes when we are creating views, reusable views, we create these closures like on, checked, on, delete, and that allows the parent to get the values from the reusable view. So in this case, it's reminder cell view, and then act on it. There's nothing really wrong with that. It's just that if you have more of these things, on, checked, on, delete, on, update, on, whatever, then you will have a list of all these closures. All right. So what you can do is kind of like separate this out into its own enum. So you can see on the top, I've separated out into its own enum. Probably you should put that enum inside the reminder cell view, but you can try to do that. And then instead of having on, checked, on, delete closure, now you have only one closure on event, and that will be the actual passing the actual enum. So the calling side will become much nicer. So we're going to look at the calling side. So this is what the calling side now looks like. So instead of doing on closure and on this and on that, you just do on event, and then you enum over it. All right. Displaying errors. Whenever something bad happens, you want to display an error in the view. Now, there are many different ways of displaying the error, but I played around with the idea of just having one location which is responsible for displaying the errors. not catching the error, but displaying the error. So again, I created a environment value. I call it show error. You can come up with a better name. And you have to pass in the error and a guidance, like what to do when the error actually happens. And then that particular thing is injected into the root of the application, as you can see. So right now I'm displaying the error as a sheet, which is right here. But you can use an alert, you can use overlay, you can use whatever you want. And eventually, when it's time to throw an error, well, hopefully you don't throw an error, but eventually if there's a time to do something, then you simply get it from the environment values and you call show error, which will show the error in the screen. All right, so now you have one place to kind of like manage the display part of the errors. So environment objects, you can have multiple environment objects. Some people think that you can only have one environment object. That's not true. You can have multiple environment objects. So over here, you can see that I'm injecting two different environment objects, counter state and authentication state, and they are used in two different views. Why would you have multiple environment objects? Well, sometimes when you have to, make sure that everything is, sometimes when you're working in a big application, you want to inject a certain environment into a certain section. So for organization purposes, you can definitely do that. And over here, we have, you just access the environment object over here, and you just use, whichever environment object that it works. Formatting. When I was using MVVM, I was doing a lot of formatting inside my view model, but I don't have to because all of this view model is available to you in different formats. You can see a lot of different formats, and I think this is mainly for dates, but you can find formatting for the measurement, you can find formatting for the list, you can find formatting for the date, which is shown over here. Everything is available right inside the view. And all of them are like, they're using the current locale that you're using, so they do take into account the locale. And for list also, so this is formatting a list. You can see that you can even format a list over here, the text, if you are displaying a bunch of people or something, then you can use a list type with an and modifier or modifier. So all of these things are available to you to use inside the view itself. And I did have some other slide, but I think I wanted to keep this session to the point. So the final thought is that SwiftUI is obviously the future of app development for iOS, macOS, iPadOS, watchOS, and all that stuff, tvOS. But the biggest lesson that you can learn from SwiftUI is just don't fight with the framework, right? I mean, I spent 3 years fighting with the framework, and I was never really happy. I was adding files after files and code after code, like a lot of files just to achieve very little. Let SwiftUI be SwiftUI. All of these property wrappers that they're adding, they are for your benefit. If you haven't checked out Swift Data, look at the implementation of Swift Data. If that doesn't give you a clue what Apple thinks of how you should be using SwiftUI, then, I mean, the Swift Data examples, like I think it's called the birding, backyard birding. So some portion of that are a little weird, but most of the app is actually really good with Swift Data, and it's a pretty large app. So see how Apple view Swift Data as an example. Now, just because something is provided by Apple or sample code doesn't mean that it's not going to work on your application, on your project. So if you want, you can go ahead and try out different variations, different, Redux pattern and MVVM pattern and MVC pattern and container pattern and all of those patterns. But what I have found out is if I just try to let SwiftUI be SwiftUI, just try to use the things that they're providing, then I'll be in a much better state. All right. The reference and slides, you have the reference and slides, you can access it at this particular location, and slides you should be able to access on Bitly. So I've added that link over there. And finally, my contact information is azamsharp@gmail.com. I'm on Twitter at azamsharp. usually don't really write that many articles, but when I do, I publish it on azamsharp.com, and you can check out my Udemy stuff on udemy.com/user/Mohammad Azam 2. And again, thank you so much for coming. I hope you have really enjoyed it. And if you have any questions, go ahead and post it. Thank you.
All right, thank you. That was a really amazing presentation. So here's what we can do. Either for people who are on Zoom, you can either post your questions in the chat or raise your hand and I will unmute you. Anyone in the room, raise your hand, I'll bring the mic over you, and I will try to make sure to alternate so we can alternate between in-person and Zoom. So with that, do we have any questions? Anyone? I see one.
Thank you. You have many different concepts here for this across the board. It's going to take a lot to think about. But specifically, I want to ask, is there any difference when using these concepts if you're doing Mac, iOS, Watch, TV, and now Vision? Because have you found anything specific to the platform which would change your approach? Because, for example, there's quite a bit of difference between the iOS interface and the desktop.
I would say, let me actually go back to that particular slide. But no, the answer is I haven't found anything different. Yes, there is a difference when I'm using a core data application versus when I'm using a client server application. Because for core data or Swift data application, I try to design it with that in mind, like with, let me see, so the one that you're saying. Okay, yeah. So with core data application or Swift data application, I'm using kind of like a variation of active records. So I'm not creating one view model observable object to rule them all. But for client servers, since the source is the server, I use that approach. But if you are building application that is for watchOS and iPadOS and iOS, then this section right here, you can also create like a shared folder or a shared UI or a shared package that you can import and start using it. But no, most of the time I've seen that it's pretty same standard. Yes, there will be some way in some points in the code where I'm using a different control for iOS versus I'm using a different control for macOS. You can, if for basic things, you can write simply if and else. You can actually do that with the hash sign. I think they're called not modifiers, but you can inject those controls. But if it's getting like a lot, then you will have to probably create a view modifier for that and hide all that stuff in there. All right. Oops, shouldn't do that. I think Ed has a question. Any thoughts on migrating an old UIKit app to a Vue-based one? I think if you're trying to migrate anything, what I've heard is that the best way to migrate, obviously, is by to do the new development in SwiftUI. And usually what I've learned is that people start with like a setting screen or something simple when they're migrating. If I have to migrate a UIKit application, which is old, to SwiftUI, I would not touch the screens that are actually working. I mean, if they're working, they're working. I don't care. They're working fine. But for the new screens that I will be developing, I would use the power of SwiftUI to develop those screens.
All right. Any other questions? Anyone else? One.
First of all, thank you for the talk. But when you talk about this pattern, do you just refer to it as model view? What kind of label do you put on it?
Yeah, I mean, this is just a name that if you search for model view, you're not going to get anything because there's really no official name for it. I think the reason we call it kind of like a model view is because we have removed the actual view model from it. So the model is directly talking to the view. But when you explain it to other people without any code, they think, oh, you're just going to shove all the stuff in the view. And that's not really the case. So yes, actually the worst part about this is the name itself. And it's not like a concrete name. I mean, some people call it model view, some people call it some other things. But the whole idea is that the view itself is a view model. And that's basically the whole point. But yeah, the name is just arbitrary, I guess, in this case. Yeah. There's another question over there. If you remove the view model layer and use the view itself as the view model, are we incorporating business logic into the view? Shouldn't the view be dumb and just present what is passed? No. So again, I think our conception of business logic might be a little bit different. So let me go to this slide, I guess. All right. The logic, actually, let me go to another slide, which is a little bit much bigger. If I can find it. Where is that slide? This one, I think this one will be much better. Okay. So again, when we're talking about client-server apps, right? The domain business logic is actually on the server. Now, if you are like, well, where do I put, if you do have a business logic in a client-server app, in the client-server app, where should I put it? If you have not the business logic, if you have the presentation logic, put it in the view itself. That's fine. All right. If you're like, well, I need to sort articles in different screens also, okay, then we cannot put it over here because you don't really want to copy paste the code into a different screen, right? So where should I put it? Well, then we should use the use case number 2, which is you will introduce an aggregate root, basically kind of like a view model, but not dependent on the screen for just one for a whole app if you have a small or a medium-sized app, or multiple ones if you have larger apps. Okay, so this is where you will add your business logic. All right, I'm calling it model, but you can call it anything you want. You can see over here I have add movie, populate movie, top reviews. So top reviews can be kind of like a business logic. I mean, if you want to do anything with it, right? I mean, top movies is just going to filter. So even that is not considered a business logic. All right. Thanks for the talk. Any thoughts on view styles or view modifier? View styles, I'm not sure what view styles. Are you talking about view extensions? View modifiers, you should definitely use view modifiers. If you are, I don't have the slide for it over here, but you should definitely use view modifier if you are putting, you know, the styles on the view, like, oh, this should be title, font will be title, and it will be rounded corners, and it will be this and that. So that will be like 4 or 5 lines of code. And you want to do it again in a different view, well, you're going to copy that 4 or 5 lines of code to make it, you know, rounded corner and this and that, extract it out, put it in a view modifier, and then use it like that. All right, so that will be much better approach if you are reusing it again and again and again. You don't want to copy those 5 lines of code again and again.
All right, we have another question over here.
Mm-hmm.
Thanks for the presentation. It's really good. Just wanted to know for the new iOS version that just came out this month, what are some of the things that you might not have covered today that you're particularly excited about that might improve development efficiency?
Okay, so the question is iOS version, iOS 17, I guess, came out, and what is good in that, which I'm excited about. Definitely Swift data, that's pretty good. Yes, it's kind of like a wrapper on top of core data, but it's really nice. It kind of reminds me of Realm framework from MongoDB, so that's a really good addition. And I'm working on a MapKit course, and yeah, no published properties also, that's good. And another thing which I'm working on a course, which I just submitted the course for publishing on Udemy, is about MapKit. They did include a lot of stuff for MapKit, including like different kind of annotation icons, a preview, a street view kind of thing they added. Map view will also work in Xcode Simulator, so it's going to show you the dialog to accept the permissions. So, using of state and environment. Bindable is a little bit weird, but yeah, state environment. So they're kind of like trimming down the stack now. So that's always good to see. I think there are a lot of things that I didn't really check out, like I think Open API stuff that they added, but I think overall it's really nice.
Right, another one over here.
So with regard to business logic on not on a client server app, but like a relatively self-contained on the device app. If, say, in your movie example, you had a movie recommendation engine that was going to say, hey, you like these movies, whatever, et cetera. That's certainly not a data model, and it's certainly not a view, but it's some business logic. How do you think about that in terms of architecture?
Yeah, so if it's definitely shouldn't go in the view because it's kind of like a recommendation engine, and it should not go in the model itself because that doesn't really work on that entity. It's more of a service, right? So I don't have an example for that. So I should probably create a service kind of similar to, well, it shouldn't be similar to that, but let me see if I can find that. Yeah, I don't think it should be, depending on what you're doing, maybe it's stateless. If it's stateless, you can create it like environment values and kind of inject it, but I don't think it will be stateless. So you should create, some people like to call it store. So you should probably create a recommendation store. And the purpose of the store is to do mundane tasks, which has nothing to do with the actual model. So the store is gonna do something, find the recommendation, maybe it will use some HTTP client or not, do the calculation, and then return it, either return it using stateless, like just return the result back, or using published properties to assign it and then publish it to the view. You can call it store, you can call it, service, whatever you want to do that. So that is where all those kind of mundane tasks that is going to go. In the articles, usually what I have seen some people, they refer it to as a store. It's going to do some stuff and mundane tasks and then give it to you. All right.
All right. Any other questions? I think we can take time for one more. Anyone? All right. Well, let's give a big thank you. This was quite a very interesting talk, and I really enjoyed it.
Thank you.
Right. I don't know, go to wrap up. If you don't mind, I'm going to need to share my screen for 1 or 2 more slides. Yeah.
Sure.
Okay. Thank you. All right. So wrapping up. Let me go. I'm not quite there yet. All right, so announcements. If you're interested in speaking, I will send this out through the meetup again. We are definitely looking for speakers for the end of this year as well as next year. So please let us know. I will send out this through the meetup so that way you can just click the link. Subscribe to our YouTube channel. I'll send out that link again as well so you can catch a recording of this meetup, recordings of previous meetups for not only ourselves, but our counterpart in New York, iOS Soho, and also the other dev community meetup groups, DC Android, DC Flutter. There's a few others in there. We do have a Mastodon now. I'm not really great about posting at it, but if you are interested there, it's at DCiOS at iosdev.space. And for the people here in person, I do have some stickers. So with that, let's go ahead. For next month, our very own co-organizer, Mac, will be giving a talk about SwiftUI and performance. I guess I hit the wrong symbol there. That will be back here next month, October 10th. Still don't know what room yet. I'm hoping maybe the space in the labs will be available by then, but if not, it will most likely be back in this room, but I will post that on the meetup when we create it. And with that, thank you, everyone, and thank you for coming tonight.
Thank you.
Another one?
Oh, yeah.
I'll put that right before truth, liberal, whatever.
A lot of meetings today.
Yeah, yeah.
Yeah, just take a nap. Take a nap right here.